holidays. Today we have a visa public holidays. That's why we meet our class today online. So hope you enjoy your daytimes, right? The celebration or you all have your holidays daytime. So please, we going to discuss our another topic. So this is second last topic for our for our subject for the further econometric. Today we're going to discuss the panel ARDL. So as we discussed, actually this ARDL, we share you the idea when we deal with the time series analysis. So as you recall, there is a topic we talk about the point integration, but we focus on the ARDL approach. So there is still remember the bound test, right, which proposed by Persara et al. 2001. So today we are going to, because now we deal with the panel approach, right? So how about the panel area? So this is the extension from the time series. So now we would like to apply in the panel setting. So there are two things we have to be caution for this panel with the panel area. There is a mean group, another one is a pool mean group. So mean group and pool mean group are the two approach to deal with this heterogeneity across the individual unit in the panel setting. Actually, what it means by the heterogeneity, since that in the time series we don't need to care about the heterogeneity, right? Because we are dealing with the time series basis, but now we are dealing with the panel, so we have to be cautious or be careful with the unit or the country we put in our panel. So because I think you are typed previously, right? For example, you are dealing with the panel analysis with your project papers or other analysis or for your group assignment. I'm sure you have experienced that, for example, if you focus on a group of 5 countries. So I think that the result will change, for example, if you exclude 1 or 2 countries from your panel. So because why? Because let's say you are not aware of this heterogeneity and you just analyze by using like the fixed effect or random effect that you analyzed previously. So you will have a potential that your result will change, will totally change if you exclude 1 or 2 countries from your panel. So because your result in the past do not account for this heterogeneity. So what is heterogeneity? It means that actually like the fixed effect you we discussed previously. So this heterogeneity will affect your result. Let's say I'm not talking about the country characteristic. I'm talking about the factors, means that the one country going to affect the result from other countries. So what we need to be cautious that we see whether the mean group is preferable or the pool mean group is preferable. So these are the two approach, econometric approach for your panel that accommodate the heterogeneity across the individual unit. So they estimate them individually and then they pool them to provide you the panel result. So they estimate individually first, not like the fixed effect or random effect like you deal with in the previous exercise. You put them together, right, for all the 10 company. For example, our US firm, right, you put them all the 10s together, then you analyze. But now is we estimate them individually first, then only use the panel approach to provide you the panel result. So let's see, we not only handle the static, we also going to handle the dynamic. So not only static dynamic, we're going to handle dynamic because this is called autoregressive distributed lag model. So not only lag for the dependent variables, we also distributed lag for the independent variables. So allow the dynamic effect in your regression. So these are the things we would like to discuss today. So I will not drag you long because today is a public holidays, right? So now we first talk about the mean group estimation. So what is mean group? So for this mean group, So for this mean group, actually is assume this estimator, this mean group estimator, I use the aberration NG here, actually assume the individual specific effect are unrelated to the explanatory variable, because each country means that each firm or country, they have their own specific effect, right? So this mean group assume this specific effect not going to affect the explanatory variable. So that estimate the regression individually. So that is the idea. So the limitation, I can say the limitation for this mean group is that assume this specific effect not going to affect the explanatory variables. So this means that you estimate the regression individually. So the parameter we're going to vary, going to different across the individual. So the individual here can refer to the firms, can refer to the country. So depends on whether you want to analyze the something like what we analyze in the class for the firm level. So that's across the firm. If let's say you, let me see. And then I open the mic, should be no problem. You all can hear me. Then I think overall okay. So okay, if you cannot hear me, so let tell me, yeah. So okay. So it can across the individual. So it means that this estimator allowed the parameters to be varied. It means that the estimate, because the estimate type separately, right? So the parameter can be varied across the individual or across the unit or across the firm, but they are constant over the time. Okay, and then after the estimate, the individual this individual estimate are then average to obtain the mean group. Yeah. So that's the idea behind the mean group. Means the first step is the estimate that individual, then the average to obtain the mean group estimate. So I can make it simple, divide into two steps. So the first step, estimate the regression individually, means estimate one. If we have time, so individual specific regression. So once you estimate the separate regression for each unit in a panel using the OS, just using a simple the estimator least square, then you estimate them separately. Then after that, we take the average. Take the average of these individual specific parameters to obtain a mean group estimate. So just average. So there is the idea behind the mean group estimation. Just very simple, right? Estimate that separately. After that, just take the average from this mean group. So it's simple to implement and can capture the individual heterogeneity. But you have to be cautioned that again the limitation with this test, because it assumes the in this individual specific effect are uncorrelated with the explanatory variable. So it might be not that valid in the reality, right? Because this individual effect have a high possibility correlated with the individual. So this is one of the limitations. That's today is the first generation. Actually, another generation, which is called second generation, that accommodate this limitation already. So if you're interested in particular direction, you can read augmented mean group. Okay. So now, because for this augmented mean group, that take into account this specific effect, and then they put in they tackle this specific effect by allowing something like they put in some factors like to factor out this specific effect. So that's why their AMG is called augmented mean group, is much more robust as compared to the mean group. So how about another estimator, which is called pool mean group? Then you will think that is it same with the mean group? So let's see how it works. So this pool mean group in the aberration, I use PMG, and also in the literature they also use PMG. So this estimator, the extent. So this estimator extend the mean group by allowing the long run relation between the variables and also the individual specific effects. It seems that it's going to solve the problem with the mean group, right? Yes. Because of this mean group, do not allowing for this individual specific effect because it's assumed that this effect going to no relationship with the explanatory variable. But in fact, there is going to have a potential uh, relationship, right? So this pool mean group is allowing the individual specific effect. So, and it's also assumed that it's also such like the mean group, they're sharing the common long run relationship for all the individual, but the short run dynamic can be different across the individual. So that is just like the similar like the mean group, because still remember the mean group just we discussed just now, they estimate the individual regression, right, individually. So actually they allow the short run across the unit, and then they use the average from this short run to get the mean group estimator. Then also applies similar with the pool mean group. So they estimate individually, then they also have a common long run. So let's see how it works. So first step is estimate the individual regression with the augmented variables. So what it means by augmented because it's allowing for the dynamic, right? Allowing for dynamic. So this individual regression with the lack of the dependent and also the lack difference of these independent variables. So it's allowing for the dynamics because for this dynamic we only able to capture the long run, right? Able to capture the long run from this ARDL, means that from these lag models. So we can have a long run relationship. So in order to, that's why different with the mean group, because for the mean group is do not have a dynamic, right? Do not have a dynamic, it straight away go to the just the static to talk about the long run relationship. So there is a little bit difference as compared to the pool mean group. So this pool mean group is can have the long run to study a long run relationship because it gives us the this individual with the lag dependence as well as the lag first difference of the independence variables, right? So you're going to have a lag dependence and also the first difference for lag dependent as well as the lag for the independence variables. So we can capture the long run as well as the short run. Then after that, in the second step is perform the pool estimation. So how it works actually is estimate the pool regression, combine the individual specific regression by taking into account the heterogeneity in the short run. So actually it's just a pool, means estimate the pool. So after we estimate them individually for this specific regression, then you can pull the regression, but you already tackle the heterogeneity in the short run, right? Like this mean group because it's also tackle the heterogeneity because they estimate them separately, right? That is the things lah. So now after they get this pool regression, then in the third step is perform the error correction. Why? Because from this error correction, we can study about the short run and long run, right? Because we already obtained the long run. So after we get this pool estimate, we can obtain the error correction. So you can grasp the dependent on the lack of this means that to form your error correction models and to study the deviation from long based on error correction. So from here you can you is perform the error correction models to get the long run and short run. So this error correction, you're able to get the speed of adjustment because you can study how fast the deviation from this the variable of interest to be deviate from the long run to go back to the long run equilibrium. So these are the three steps in the proving group. So the pruning group actually in the literature is say provide a consistent estimate of the long run relationship and allow for the individual specific dynamic. So that is the advantage now as compared to the mean group, right? Because why? Because it's combined the mean group, right? Because you can study about this pull them together. Actually, they use the pull mean group idea lah, but there is also tackle the long run relationship as well as the individual specific dynamic. Actually, we can get from the fixed effect because the fixed effect is allowing for this individual effect, right? To study about individual effect because that's why this pool mean group combine the advantage from this mean group as well as the fixed effect estimator, but allowing for the individual, what we say the heterogeneity like in the short run. So now, so what is the what we say the summary, right? So what is mean group? Mean group actually estimate the individual and then average the individual estimate. But the pool mean group extend this mean group, incorporate the common long run relationship, so we can study the long run and short run, then together with the dynamic. Okay, so then you talk about how to choose is mean group or pool mean group. But after you look at the advantage with the pool mean group, I'm sure you will go for the pool mean group, right? Because going to be dynamic, so you can study about the long run and short run, and you also can tackle this what we say the heterogeneity as in the mean group, right? So now, so how about the panel AIDL? So this one just a little bit different as compared to the idea we discussed previously. So this is pool mean group, right? So how about the panel AIDL? This panel AIDL actually is the least square regression, just like we did in the time series. We estimate the AIDL model with the least square approach, right? Yeah. So but in our model, not only the lag for the dependent, we also got the lag for the independent variables. So these are the AIDL lah. So if we combine in means that combine the time series and cross sectional, so we can actually use the panel AIDL to achieve this objective. So then you will ask what in the panel setting, right? Because we combine the time series and also the cross sectional. So you're going to have what we say the individual effect, right? So that's why the going to have uh between repressor and also the error terms. Cross dependency is in this forming group because this panel RDL is extension from the forming group, right? Because it's extension for the forming group, we use the forming group idea and then extend the model but incorporate this autoregressive term and also the distributed lag term in the repression. So it might be have a problem like the cross dependency which had to be tackled, right? Had to be tackled. So now, actually this bias only vanish for the large number of observation, right? So you can something like you can reduce or you can minimize these problems if you have a huge number of observation. So the T, yeah, so the T, but you cannot solve this one by increasing the cross section. So this is referred to the N. So it means that these problems can be solved if you increase the T. But this problem cannot be solved if you increase the N. Because the N here refer to the firm, for example, like my T in our discussion, I have 20, right? Then I have the firm is 10 firm. So if I want to use this panel AIDL, actually will be biased because there is a correlation between the mean difference regressor and also the error term. So in order to solve this, I have to increase the observation instead of increase the number of firms. So the larger the number of observation will tend to solve the problems. Then how about the small t and large n? So for the small t and large n, for this case, so cross dependency is an issue, right? For a small t and large n, because you involve many firms, for example. If that's the things, we have to use the GMM now. We can use the GMM for the large end. For the large end, like for the huge unit or country, for example, like the above 50 firms or 50 countries, right? So in that scenario, we suggest you to use this GMM, right? So how about large T? For this huge T, for this large T, like the observation, like our case, like the observation, right? So, and then I only have 10 firm. So for this case, you can we can use that this what we say the panel ARDR, but we have to be cautious, right? Be cautious, we have to increase the T if possible. So this is much more appropriate for the long panel, actually long panel. So for this large T, if you have a many T, you have a long T, but very short end, actually the GMM is not appropriate. GMM only for the if your panel setting you have a many end, then GMM is appropriate. If you have a very small end, then GMM actually not appropriate because the estimator breakdowns here. Okay, so what you need to do is if we have a large T, in this case, we need to use this the test proposed by this Pasaran et al. 999. Actually, Pasaran is proposed by Pasaran, Shin, and Smith in 999. So it's actually a form of pooling group. Some people call this Pasaran, Shin, and Smith 999 as a pooling group. Some people also call as a panel ARDR. It depends on what kind of model you are dealing with. So this model actually take the co-integration form of this ARDR and then just put it in a panel setting. Yeah, it in a panel setting. But this model allowing the intercept, it means because, for example, I have a 10 firm, right? So if I apply this pooling group or panel ARDR for my data, is actually is allowing the different firm with a different intercept. So they have a different intercept and then they have a different coefficient. Same coefficient for the long run because they use the pooling group idea. So we're going to have only one value for the long run, only long run. But for the short run, going to be different, going to be different. And the co-integrating terms also different across the cross sections. So just like last time, estimate one by one, right? For example, if I 10 firm, I ask you run the ARDR, you're going to run 10 times, for example. But now you only run once by using the pooling group ideas. Okay, so let's see how it works. So this is my pooling group model. So you can see I have the changes y as my dependent variable here, right? Changes y as my dependent variables. And I have the lag for my changes y, right, on my right hand side, because these refer to the AR term, right, autoregressive. How about distributed lag? So this refer to the distributed lag for my independent, not only distributed lag, also their independent variable, as well as their distributed lag for my independence variable. So for a set of independence variables, okay. So this refer if you have one independent variable, so it's referred to x, for example, right? So you have your current changes in the x, also got the lag one for your changes in the lag. So this refer to the changes in the x for your independent variable. So we start at the 0, right? So it means the current one as well as the lag period. So depends on how many lag you put inside. So this refer to the DL term, distributed lag, and this refer to the AR lag for your this refer to the AR term for your autoregressive. So actually we have a different type of the distributed lag model. So distributed lag, it means that for the first one is the distributed model, means lag for your independent variable. The other one is autoregressive, means refer to the lag for your dependence variable. So how about another one more variables that you observe here is the EC. This EC actually refer to the residual. Refer to the residual. So what residual? Residual flat one period. So this DC refer to the error correction term. Refer to the error correction term. Actually, it's from the long run, right? From the long run, then actually is y minus your y head. Yeah, this is y, right? This is your y and the y head. So you can form your error correction term and then let one period. So you put inside here. So this is the panel ARDR approach, right? This is what we say the this is the uh panel ARDR model. This panel ARDR model. So from this model, you can form your what we say the long run and short run. Okay. So it's assumed that in here, right? You assume that your dependent variable and also your regressor have the same number of legs, right? For example, you say Q, it means that the Q, let's say you have imposed 4 legs for your independent variable and 4 legs for your dependent variable. So you're going to have a same legs for all your cross section, right? But actually in the practice, right, it's not like in the practice going to be different, right? Like different country going to have a different slabs. So depends on the we will use the model selection criteria to help us to get the the next minimums the models. So this person at all 999, they use the how they choose the model is subject to this log likelihood function. So I'm not going to discuss in detail lah. Actually, the idea behind this Perseverance at all 999, they use this log likelihood function to provide you the final models lah. Okay. So we try to maximize directly lah, because they choose the model is based on the higher the log likelihood, they will choose that models, right? So based on the log likelihood ratio. Okay. So now, and also it also involve the iterative procedure lah. Iterative procedure that they're based on this iterative procedure. So when you use the e-views to run, they will based on the iterative procedure, and then they will choose the model that provide you the highest this log likelihood ratio lah. Okay. So now, how we can estimate by using our e-views, right? So now, before we you can open your e-views, like you can open your e-views, like we can open the pool version. Like I use the config part 2, for example. So I close this one first. Okay, close this one first. So again, here this is our work files we use in the past. So here I have again introduced you again the sample period start from 1935 up to 1954 for the 10 firms. So totally I have 200 observations. So my n is greater than the t. So sorry, my observation is greater than the number of firms. Yeah, number of firms. So I only have 10 firms. I have 20 years. So my years is greater than the number of firms. So now, and also the ARDL like as previously, the East panel ARDL also share the similar idea, which is not something like is used to capture the I1, I0 variable as well. So still remember in the last week we discussed about the panel core integration, right? So for the panel core integration, we have a several type, right? We have a Gao, we have the Johansson, we have the Pedroni. So to come up to see whether the variables of interest are they co-integrated in the long run or not? So this panel ARDL actually share a similar idea like the time series ARDL. Also, with the idea that it can allow for mixture of I1, I0 variable. But for the Petroni, for the Gao, and also the Johansson, it has to require all the variable should be I1. Cannot have a mixture I1, I0. So there's the conditions behind, or what we say the thing we have to be caution now. Like you say, just like okay, not all your variables, like if you have 5 variables, then mixture of I1, I0, then the literature propose you to use the ARDL, panel ARDL or ARDL, because this estimator allowing the variables that either I1 or I0, mixture of I1, I0, but not for the Johansson, not for the Petroni, not for the Dow integration test. That test is required I1 strictly. So if because it's very not common, right? Because some variables might be I1, some variable will be I0. Let's say the interest rate is have a high potential to get the I0 variable because it's fluctuated around the mean, and also the variance for the interest rate actually constant. But for the GDP or for the investment series, actually it will be follow the I1, right? Because they are not going to be stationary in the level. So you are going to have a mixture I1, I0. So okay, so now I'd like to show you, demonstrate how we can run this panel ARDL. So I click on my my dependent variable first, then followed by my independent variable, which are the CAP and VAL. Then I open them as a equation, right? Open them as an equation, and then this is just a pool setting, right? Pool setting. If you run such equation, it's a pool setting. So if I scroll down, I can go to the PMG. PMG means refer to the pool mean group or stretch ARDL. So this refer to the pool mean group, or we call as the auto-regressive distributed lag models. So once you click on this button, you will come up with this equation estimation work files. So as you observe here, in the first row here is the dynamic specification. So it's you don't need to do anything here because you're going to allow for dynamic when you set the lag here. So what is your dependent variable INV? Then followed by the regressor. My regressor will be CAP and VAL. Then again, the regressor specification here. Once you scroll down, actually these are the case 1, case 2, case 3, case 4, and case 5 discussed in the original paper. So I would like to restrict for the constant, means I include the constant in my estimation. Then fixed regressor means it do not allow the lag. If you first say you have the ideas that VL will not going to have the lag effect on this investment, so I put here. But now effect VL on the investment. And for the lag selection here, I put the automatic selector. So I let the it to help me to select the maximum. So and then I put here dependent and requester. Dependent to the lag up. Then requester means for the D. So ARD, called ARD. Auto regressive dependent variables. So here I put maximum 4. Actually, you can have a different different lags. So different lag, for example, I put here maximum lag 2, then regressor maximum lag 4. But you need to have a reason why you put 2 or 4. So let's say I deal with the modeling, then I put lag maximum dependent, 4 lag for the for this dependent, 4 lag for the AR terms, 4 lags for the VL terms, distributed lag terms. Then I go to the option here. Here, model selection criteria, once you scroll down, there's an AIC, SC, and the HQ criteria, right? So I use the AIC. So then other than that, you just make it same. But this is account for the asymmetry. So for this moment, I just click OK. So once you click OK, then it will give you the result here. So this is my ARDL result. So it provide you the log likelihood ratio is -491. Okay. So based on the maximum lag 4, then my model is PM pool mean group means panel ARDL 444. So 444, what it means? It means that 4 lag for my AR terms, then 4 lags for my CIP and 4 lags for my VL. So again, this one is they use the what we say the short run and long run because of these ARDL models, we can calculate, right? Can calculate for the short run effect and as well as the long run effect, like what we did for the time series. And this short run is based on the mean group coefficient. Then for this short run, actually is allowed for the heterogeneity, right? Heterogeneity, and then use the mean group and then provide you the mean group estimation here. This was short run result from this independent area. Then this is the speed of adjustment. This is error correction term, which is means that 49.79% for this variable of interest to corrected in the long run. So you see how fast this deviation to be corrected in the long run is around 49.79%. Actually, it's also significant. It has to be between 0 and -1. Right, it to be between 0 and -1, so it's negative 0.49 and then negative significant at 1%. Then how about the long run? So these are the long run. These are the long run coefficient, constant, as well as the coefficient for the CAP and BAR. So all the variables, including the constant, significant at 1%. So again, this long run, this one is actually allowing, what is the panel layout idea is, it's allowing for the individual, right? Yeah, allowing for individual. So you have a common long run relation, right? Individual specific dynamic. Because this pooling group extend by incorporate this common long run and also the individual specific dynamic. Okay, so that is the advantage behind the pooling group. So now, what else information you can obtain from this pooling group is, you can go to view, then you can go to what we say this ARDL diagnostic, right? Yeah, ARDL diagnostic. And then you also can check for the residue diagnostic and also can go for the coefficient diagnostic if you want to do some more tests. So before that, come here. So now it's based on log likelihood to maximize the log likelihood. Okay, so this is the thing we do just now. We go to estimate and then the equation and then select the pooling group. So you give you the ARDL dialog, right? So you give you the specification and then you can see your dynamic specification and also the automatic selection and also the fixed box. So you can type in your variables, right? So dependent and then followed by your independent variable. Then you can choose automatic. So you can put the maximum net, right? Just now, maximum net 44. So if you use the fixed lag, it means that you impose the fixed lag for your variable of interest. So because just now you put the maximum lag, right? Let's say I go to estimate. If you put the fixed lag, it means that you fix the lag. So you are no longer like just like you fix 444, you get a similar result of 444. So let's say you do not you want to fix the lags. So if you based on some theory, you want to fix the lag like 2 for the dependent and then 1 for the regress or 0 for the regressor. So you give you a different result, right? Give you the different result. So this will be your short run result, right? Short run result. We'll give you the different result here. So you give you a long run as well as the short run. Okay, the short run. So here is your yeah. So what you means that if you put regressor is 1, right? Regressor is 1. So you're going to in the short run, right? So it's actually you're running the 211. Or maybe I can rerun again. But if you want to put like this, so you're going to have like such equation, right? So this is a panel ARDL 111. You mean one flag for your dependence, one you mean in your ARDL model, one lag for your independence variables, it means which is CIP, and one lag for the VL. That's why first difference. So you study about their the planet ARDL 111. So still is the ARDL around the day, but now you can see a short run as well as the long run impact. So if let's say you allow the system to choose for you, like this we start with maximum 4 lakhs, so you can see the result, right? Okay, so estimate, then you can see, so still remain, so the CIP remain not significant and the VAL turn to become not significant already, right? When you finish the panel area 444, right? 444. So that is the difference, right? If you fix it, you want to use that the criteria log likelihood criteria to maximize the models. So now the system chooses you 444, right? So you can have the justification why you based on the maximum lag 4 and then and then this system evaluates based on this likelihood, maximize this likelihood, and then they show us the panel ARDR 444 actually is appropriate here. Okay, so that's the maximum lag. So if you select the fixed lag, so the same menu you select the dependent and also the regressor. So how about the unlike the non form of ARDR model, so each regressor will give the same number of lag even though you use the selection. So if you fix the lags right, you are saying something. So how about the fixed regressor just now? So the fixed regressor button just now, it means specify the fixed variables. So without the lags. So like just now I put it here, right? So it's not here, it's this one. Like I go to estimate, if I choose here fixed, right? Like the VL, I choose here fixed. So like the VL, I choose here fixed. So what will happen? So on will appear like this. So VL will be like the fixed in the short run, right? Will be the interface in the short run and no changes, like no changes. So if you fix the regressor in the what we say the fix the regressor in what we say the panel ARDL, so it will appear the short run will be appear in the level form, right? In the level form, and it will not appear in the long run, right? Because you just fix, you just have two only, right? You just have two because your dynamic specification, INV and CAP only, and then you allow the VAL to be fixed, not dynamic. So it will not appear in the long run, not estimation. It just appear in the short run and in the level form. So that is the adjustment, right? You have to be careful. So if you have a reason why you want to have a fixed regressor for the variable, then you need to put under this column. Okay. And what else you need to do is the trend here. So specific whether you put a constant or trend or neither. Then also the list of fixed regressor blocks like you said just now, put in the variable that you think is dynamic. Then you also need to choose the lag length based on the model selection criteria, which is the AIC, SC, or and then Q criteria. Again, you can choose between the AIC or SIC. Like just now, I based on AIC, it support me the panel ARDR 444. How about if I choose the option like AIC model selection criteria? If I click OK, so the result will be panel ARDR 101. If 101, right? So my long run estimate still significant, right? At 1%. Then my short run estimate, right? I only can get my coefficient because I in my panel ARDR model is zero lag. Is zero lag for the CAP. So it means that lag for my one lag for my auto regressive term, and then zero lag for my CAP and one lag for my VL. So I can compute their first difference, right? For the VL, but not for the CAP. So CAP cannot observe in the short run already by setting the panel ARDR 101. So as you see, the AIC will provide you the maximum lag, right? 444, but the SIC will suggest me 101. So different information criteria will have a different output, right? Different output. So you have to be cautious, right? So this is the things we discussed just now. So these three variables, and then you put 44 here. This is the setting with the EView 12. With EView 12, I think that will provide you the similar answer. Okay, so we have a long run. We also have the short run equation. So okay, for the 444, yeah, 444. Then you can see the method here, ARDL, and based on maximum lag fall, and based on AIC, right? Fixed regressor is constant. So actually, eViews not straight away give you the 444 directly. It's based on the number of model evaluated. It's based on 60. So they have a different combination. Then based on the model selection criteria, they propose 444 will minimize the AIC value. So how I can see this 16, right? So here, number evaluated is 100. It's based on SIC. Then the eViews help me to evaluate 100 equation, then suggest me 101 actually minimize the SIC value. So let's see, I go back here to take a look the AIC. Okay, so once I take a look here, then I go to view, and then check for this model selection summary. You can take a look at the table. So this table provide you a lot of the models, right? A lot of models. See, all these models, they suggest 444 instead of 434. If 434 means that AR means that the lag dependent variable is 4, then CAP is 3, VAL is 4, right? So, but now it suggests 444 because this model provide me the minimum AIC as compared to the model number 6. This model number 6. Then this model is provide you minimum uh, lesser value of AIC as compared to model 11. So accordingly, right? So these are the output from these e-views. So you can show use the minimum minimum output minimum AIC value. So it's actually 444, right? Actually, it's based on 100 model of estimate, 100, right? But just now, my e-views 12 output is just based on 16. So based on 16 model based on 16 models, then it suggests 444 similar result even though just have 16 model evaluated. So okay, so what else? You click okay, right? You'll come up with see the result. So so what is the result? Not only long run, you also can see the short run coefficient. And actually the short run, right, are the mean of the cross-sectional specific coefficient are the mean value. So mean value for the short runs coefficient is a mean value. Then actually you also can do the post estimation. So what post estimation? We can view the individual error correction model. We can view the model selection summary, etc. So let's see. These are the things that these are the post estimation based on the model 16. The model you use provide to you. So now this is criteria graph or criteria tables lah. So the graph shows you the best model with the lowest criteria value, like what we discussed just now. You also can based on the graph. So how I can produce this graph? So based on this graph, actually it's a very show you the minimum values, right, as compared to other model. So here you show here, you go to the e-views, then you go to the view. Then for this ARDL model selection summary, you can choose the criteria graph. So this criteria graph will show you that the model provide you the minimum AIC value as compared to the another model. So again, ARDL 444, right? ARDL 444. These are top 20 models reported in the e-views here. So if you want to export the figures, you just copy to the clipboard and then just paste normally. Okay. So you also can see the short run coefficient. So what are the short run coefficient? I can take a look from my result. So as is here, ARDL diagnostic, right? So for this ARDL diagnostic, so just now we show is the mean, right? Mean value for the cross section. Actually, we also have this cross section error correction result. So it's a cross sectional. So once you click on that, so because I have 10 firms, so I'm going to have a 10 equation. Right? So remember the idea behind the proving group, estimate them individually first, right? Yeah, estimate the 10 equation first. Then only then that you can form your pool result. So we also can get the individual error correction model. So you can see the for the firm number 1 up to firm number 10, right? Yeah, there are short run result. These are the short run result. So what else I can see? Short run result. So you can explain for a short run result, like you say, what are the impact of this this CFP on the investment and VAL for the investment for this firm number 10, right? And also the impact of short run CFP and VAL on the investment for the firm number 9 accordingly. Okay. Then these are the 10 firms. And you also can get the to do the some diagnostic test. So for example, the what we say the normality. So to see whether the residual from this and ARDL is it a normal or not normal? Or is it follow the normal distribution or not normal distribution? So what we can do here is go to ARDL diagnostic. Is it here? No. Sorry, it's the residual diagnostic. Go to the normality test. So from this normality test, this is the result. To see whether the residual from my pooling group are they follow the normal distribution or not. So here, Jack-Barra statistic is highly significant. So based on this Jack-Barra, actually normality test is proposed by Jack-Barra. Then PROB, the probability here is referred to the p-value from this Jack-Barra, which follow the, actually we need to compare with the chi-square distribution with the 2 degree of freedom. So it's highly significant because p-value also highly significant at 10%, 15% or 10%. So highly significant. So we can reject we reject the normality. So the residual for our panel area actually not follow the normal distribution. Okay. So what else you can take a look from our result here? Yeah, diagnostic, right? Not only the error correction, we also can look at the bow test. So for this bow test, so still remember in the time series, we compare the bow test, right? Compare the bow test with the critical value to see whether the variable of interest are they integrated in the long run or not, right? So here we because they run them individually, right? That's why we do not have like the Petroni integration like the Gao and also the Johansson provide you the lump sum result. Provide the lump sum. This one is just provide you the cross-sectional bow test. So based on this cross-sectional bow test, instead of running one by one, so this cross-sectional bow test show you the bow test for these 10 firms. So again, you can compare with the critical value here. So which firm actually they have a co-integrated in the long run, right? So you can compare with the, again, there are 2 set of critical value with the bound test here, with the lower bound and upper bound. So 10%, 5%, and 1%. So because my sample is quite small, right? 16, so you can compare with the 30 here, 30 observation. This is the lowest one, right? So again, you can compare, see which firm actually from 4, 4, 5, 6, right? Is it 4, 5, 6? Yeah, sorry, 5, 6, 7, 5, 6, 7, and 9, right? 5, 6, 7, and 9 actually greater than the upper bound of the critical value. So there is a co-integrated in the long run for the firm 5, 6, and 7, as well as 9, right? Because of this 1, 2, 3, 4 are greater than the critical value upper bound. So, and also number 5 is greater than the 5%. So the at least significant at 5% for this 5, 6, 7, 5, 6, 7, and 9. For this 5, 6, 7, and 9 for these 4 firms. Okay, there's a co-integrated in the long run. So there's the bound test we can study. Oh, no more. Okay. So that's the thing not in my notes, right? For this bound test. So let's me take a look what else we can do with this ARDL. Oh, not this, okay. So not only that, you also can do some what we say the PMG similarity test. Because just now we got discussed about the pooling group, right? As well as the mean group. So for this pooling group similarity test, once you click on it, actually provide you the mean group estimation as well. So as we know, the mean group a bit different compared to the pooling group, right? This is the mean group result. So mean group actually is different a bit compared to the pooling group. So the mean group ideas, remember, the mean group idea is this one, the mean group. So this is the mean group. So estimate and then assume this what we say the mean group is assume the cross-sectional. It means that the individual specific effect are uncorrelated with the explanatory. So this assume that assume these two uncorrelated, right? Assume this got uncorrelated. But for the pooling group, so different. We combine, right? Combine the what we say do not assume because it's assume the common, and then it allows the short run dynamic to differ. So to differ across the individual. So try to extend the mean group, right, to allow for this individual specific effect. So to allow the individual specific effect, so this is the advantage lah, for mean group compared to the mean group. So then you will ask, is it mean group better or poor mean group better? So actually we can use this test to justify, is it poor mean group better or mean group better? So again, the mean group idea here do not allow the heterogeneous, something like do not account this specific country effect, right? Do not account the specific individual specific effect, but the proving group, yes. That's why the result is so different. Just now the result VAL here significant, but this result is not significant. So which one is better? It's based on the result here. So we shows that the similarity test actually is a Houseman test. So this is a diagnostic test for us to choose between the mean group or poor mean group better. So if you this one fail to reject, then you need to report the mean group because there's a no heterogeneity. But what is the hypothesis here? Estimator is similar to the poor mean group, but now is significant. So significant means that the H now here is estimator is statistically similar to the poor mean group, which means that there is no difference for you to use the mean group or poor mean group. But now you reject it. You reject it, right? You reject the H now here. So it means that the estimator now actually is no different. It's very different compared to the poor mean group. That's very different, especially their coefficient. Their coefficient is very different. Why? Because you see the mean group here, this is the result for mean group, but this is the coefficient for the poor mean group, right? This is the result for the mean group, and this is the coefficient for the poor mean group. So if you compare here, right, this one 0.27, this one 0.04, because this one do not allow the specific individual effect. This allow for the specific individual effect, right? So here, and also based on Houseman test, these two actually very significant difference, and the test also reject the hypothesis. So what we can say that poor mean group is better than the mean group because poor mean group is provide you the what we say the because poor mean group is an extension for the mean group, and now the mean group and poor mean group provide you the two different results. Based on Houseman test also show that the two coefficient actually is a different the estimator, means that the mean group estimator actually is different with the poor mean group. So with such a situation, we will choose the poor mean group result. So poor mean group is a better result as compared to the mean group here. So we can report here is positive for the VAL instead of negative. Okay, so there is a difference here. So far so good. Wow, now it's 7:14 only. Still early, right? Then you say, oh my God, am I going to drag you? Am I going to drag you until 9? No. So don't worry, I'm not going to drag you until 9 o'clock. So don't forget to check your attendance, yeah, in the Spectrum later if you forget to check your attendance. So you log in the Spectrum and then just click on the check your attendance for today lah. So okay, so any questions so far for this poor mean group? So as we aware that next week going to be our what one more week, right? We're going to make physical to discuss about the problems in our panel estimation. Then in the week 13 going to be our online quiz. Yeah, going to be our online quiz, and I plan to do the online quiz not physical. You can do it at home or do it at anywhere. Don't do it in a shopping center. Yeah. So don't do it in a shopping. Do it in a shopping center. You still can use our lab. Our lab is available to do your online quiz. You can do it at a lab here, or you can do it at home. Depends on you lah. So it's online quiz. We schedule on the week 13. Okay, week 13 is online quiz. It's a MCQ. Yeah. So you have a choice to choose for that one lah. So the format is like that. It's an MCQ question. Then you just need to spend like the 1.5 hour for this online quiz. So that's one we will discuss detail in our next physical meetings for the coming lecture in the week 12. Then week 13 is our online quiz, and week 14 will be our revision week. Okay, revision week. So that's all only lah. Let me see what happened here. Oh, attendance page. Yeah. Let me check my spectrum. Is it I forget to click something? Is it? Let me see. Let me see. Maybe I forget to allow the student to check. Oh, it's blank, is it? Let me see. Oh, okay. Wait, I forget to click something. Let me see, let me see. Luckily you tell me, wait, 18 until 21 today. Yeah. Okay, I forget to add. Now should be okay. Thank you for letting me know. Let me check again. Yeah, I think okay, right? I think some of you already can check your attendance already. Yeah, good job. So okay. Okay, thank you. Because sometimes I create there, right? I forget to make it to add in the section. That's why it's not appear in your page. So that's why it's blank. Right? Thank you for letting me know. So okay, so any more things want to discuss today? Let me check. Don't forget to go through the papers. Yeah, I upload the spectrum. In my spectrum here, there is a file, right? Like Persara at all 999. So for the, because today we just discussed about the mod and breaker side, right? For the idea behind the Persara 999, you can go through the paper actually. Actually now people also talk about the cross section dependency, not only this individual specific effect, they also talk about the cross section dependency in the pooling group. So you can take a look at that kind of paper and then see how you can incorporate the idea lah, the idea behind this one. Okay, that is theoretical paper, yeah. Which published in this Journal of American Statistical Association. It's quite a tough paper, I know, but it's highly cited. For those want to use the panel ARDL or Pooling group, they have to cite this paper. Lah. Okay, there is the foundation of the Pooling group paper. Okay. So any questions so far? I think so far so good. So far so good, right? Yeah. So I will not drag you so long. If anything okay, then we will see you next week lah. Okay. Wait, let me see. Do the online quiz. No, not next week. It's week 13. Week 13 is our online quiz. Yeah. Week 13. Week 13 is an online quiz. You can do it everywhere. Not necessarily in our lab. You can do it everywhere. So yeah, it's so we will discuss the format next week. But the online quiz week 13. So week 13 is 5th June. Yeah, 5th June. So we're going to meet physics on 29th May. Then 5th June, we're going to do the online quiz. But I don't think it's I normally will let the online quiz do it at home now. Okay. So you can spend your own time to do it, your online quiz everywhere. Yeah. So 5th June, yeah. But in a spectrum, in a spectrum. So make sure your internet is stable. If your internet not stable, please come to campus. Please come to the lab. Okay. And then for next week, we're going to move to the bigger lab. Yeah. Our lab will be in the now G2, G3. So now G2, G3, yeah, which is not is near the museum cafe. Near the museum cafe. Yeah, there's a bigger lab for you to enjoy there. But because the lab just ready in this in last week, yeah, lab just ready last week. So that's why we do not have a chance to use it. Do not have the chance to use it. So in the next week class, we're going to enjoy the lab, but it's very far from the Bio Cafe, but it's very near to the Museum Cafe. Okay. Then in the week 13, we're going to enjoy your online quiz. You can do it everywhere. If you have an internet issue or the PC problem, you can come to the Macmau G2, G3 lah. But I'm not gonna be there. I'm not gonna be there. So I will somewhere, somewhere. But you can enjoy the Macmau G2, G3. Then the week 14 will be our revision lah. We're going to make physical. Yeah, leg room. Yeah, correct. Correct. It's a bigger lah. You need to walk a lot. Walk a lot. Yeah, it's near the H010. I think it's near, it's behind the Brock H10, correct? I think it's a H9, H8, sorry. It's near the utility lab. Yeah, correct. Near the utility, it's level 1 is the utility lab, right? Then level 2 lah is the Macmau G2, G3. Okay, I'll see you there. It's okay, if yeah, correct. Yeah, so next week we're going to meet at the Macmau G2, G3, correct? Because I want to bring you to the new lab. So we go to meet at the G2, G3 in the week 12. Okay, so I will do the formal announcement in the spectrum. Do I understand that some of you missing here, right? So I will do the formal announcement in the spectrum later. So please enjoy the journal articles and please practice that. And actually you can go to the website to download the related articles, see how people interpret the result, right? Because my interpretation might be limited here. So you can go to the interpretation, see how people interpret. For example, if you want to apply for your group assignment, you can see how people interpret that. I try to get you some and then up in the spectrum if I found it. So okay. So if nothing, then I let you all go to enjoy your break. Yeah. Or for those want to have a break, to have a dinner, then let's go ahead. So see you all next week. Bye. Oh, thank you. See you. Bye.